Yes, good morning. Today we'll discuss about the authentication and encryption on constraint networks. As we have seen in the last class about the RPL, it is a routing protocol for low power and lossy networks. And today it is authenticated and encrypted on the constraint network. Let us see. The IETF working groups that are focused on IoT security. So there are two working groups are there. One is ACE and DICE. ACE is nothing but authentication and authorization for constrained environments. Working group is tasked with evaluating the applicability of existing authentication and authorization protocols and documenting their suitability for certain constrained environments use cases. So here ACE works on, it focuses on COAP, that is Constrained Application Protocol, with the Datagram Transport Layer Security Protocol, that is DTLS. This ACE group expects the procedure, a standardization solution for authentication and authorization that enables authorized access, that is get, put, post and delete, to resource identified by a URI and hosted on a resource server in constrained environments. And unconstrained authorization server performs mediation of the accesses. So basically this is going to be one of the protocol where authentication and authorization is done for constrained environments. Another group, that is DICE, as a new generations of constrained nodes implementing an IP stack over constrained access networks are expected to run on an optimized IP protocol stack. You have seen this IP protocol stack before. The DIC is nothing but it is a DTLS in constrained environments. This group focuses on implementing DTLS Transport Layer Security Protocol, that is Datagram Transport Layer Security Protocol, in these environments. The first task of the DIC group is that to define an optimized DTLS profile for constrained nodes. In addition, this group is considering the applicability of the DTLS record layer to secure multicast messages and investigating how the DTLS handshake in constrained environment can get optimized. Now, these are the two working groups which works on the protocols. How these things are getting implemented in this. So here the profiles and compliances, which defines certifications and promotions by alliances can help implementers to develop solutions that guarantees interoperability and interchangeability of the devices. When we are going to communicate between the two devices, these things are essential between the IoT devices. Some of the main industry organizations working on profile definitions and certifications for IoT constraint nodes and networks are IPSO Alliance, that is Internet Protocol for Smart Objects. Second one, Wi-SUN Alliance. Third one, Thread. Fourth one, IPv6 Ready Logo. What happens in IPSO Alliance? This alliance initially focused on promoting IP as the premier solution for smart objects communications. It works on IP. Today, it is more focused on how to use IP with IPSO Alliance, organizing interoperability tests between alliance members to validate that IP for smart objects can work together and properly implement the industry standards. Whenever we do the projects on IoT, so based on this protocols only that will be going to work. So at that time, this is very much essential that how it going to cooperate for the industry standards. Second one, Wi-SUN Alliance. Wi-SUN's main focus is on IEEE 802.15.4G. This is a protocol and supports for multi-services and secure IPv6 communications with applications running over the UDP transport layer. So n number of applications are going to be present on this. So majorly two protocols are going to be considered in this. One is 802.15.4G and IPv6 communication. The utilities industry is the main area of focus for the Wi-SUN Alliance. Wi-SUN is a FAN, that is a field area network. Profile enables smart utility networks to provide resilience, security, and cost-effective connectivity with extremely good coverage in a range of topographic environments from dense urban neighborhoods to rural areas. Wherever that applications are going to get implemented, these things are going to be considered for the effectiveness of the application. Next comes about the thread. This is another group. It has defined an IPv6 based wireless profile that provides the best way to connect more than 250 devices into a low power wireless mesh networks. Different again applications are going to be present for this, where we use IPv6 based wireless communications. IPv6 ready logos. Another profile it is ready logo program has established conformance and interoperability testing programs with the intent of increasing user confidence with implementing IPv6. So here IPv6 is already existing, but with the testing on that, any applications, there will be more confidence for the implementation of IPv6. IPv6 core and specific IPv6 components such as DHCP, IP secure, then the customer edge router certifications are in place. So here there are so many protocols are going to be used for again on the IPv6. Thank you. Next, let us concentrate on application protocols for an IoT.